let's do a couple of example formulation problems. Okay, so our first problem is to formulate 1 ton of feed containing 12% crude protein on an as-fed basis using ground shelled corn and ground alfalfa hay that was harvested during the mid-bloom stage. And then if this diet is to be fed to replacement ewe lambs that are roughly 70 pounds in weight, will it meet their dietary requirements for calcium and phosphorus? Okay, so the first step in formulating the diet by hand is to make a table. Okay, so our first table is a table that shows the ingredient composition. Okay, and then after that, we want to state the animal requirements. So first, let's make our table. So we have the ingredient. We've got corn grain and alfalfa. And then we plug into the table their dry matter content, crude protein content, calcium content, and phosphorus content. And we indicate here that these contents are percentages on an as-fed basis. Remember, we need to always be aware of whether we're expressing these units on an as-fed or dry basis and that we're consistent. Okay, so we've got our ingredient composition table. We know how much dry matter, crude protein, calcium, and phosphorus are in our corn grain and alfalfa, so we can then use them to formulate the diet. So then we state our requirements. We have replacement ewe lambs that are 66 pounds in weight. And we know, based on the NRC requirements, that they have a requirement for calcium at 0.53% of the diet. That's their minimum requirement. They need to have at least 0.53% calcium in the diet. And for phosphorus, 0.22% phosphorus. And you'll notice here, I indicated this in the color blue, these requirements are on a dry basis. So bear that in mind. We made our ingredient composition table where the units are expressed on an as-fed basis, but the requirements of our animal are on a dry matter basis. And you'll notice that the calcium to phosphorus ratio, okay, is at least a 2-to-1 ratio. So again, we need to be mindful of our calcium to phosphorus ratio. Okay, so let's use the Pearson's square method to solve this problem. So let's make our square. We want a diet that contains 12% crude protein, which we put in the middle of our square. And then on the left side of the square, we put our ingredients and their crude protein contents. So corn, which contains 8.5% crude protein, and alfalfa on the bottom left, which contains 15.3% crude protein. Then we subtract along the diagonals, always subtracting the smaller number from the larger number. So if we start with the alfalfa, 15.3 minus 12 equals 3.3. And then for the corn, 12 minus 8.5 equals 3.5. The 3.3 and 3.5 added together equals 6.8. Now, to determine the amount or the percent of corn and alfalfa in the diet, we simply divide that number on the right side of the square divided by the total number on the right side of the square. So the percentage of corn in the diet would be 3.3 divided by 6.8 times 100 for a total of 48.5% corn. The percent alfalfa would be 3.5 divided by 6.8 times 100 equals 51.5% alfalfa in the diet. And you'll notice using the Pearson's square method that this method works well for 2 ingredients at a time. Okay, so now that we've used the Pearson's square method to solve for the amount of each ingredient to be included in the diet that provides the desired level of protein in the diet, we need to determine whether the diet will meet the calcium and phosphorus requirements of these ewe lambs. So for calcium, we have 48.5% corn in the diet, remember, which we just determined using the Pearson square method, times 0.03% calcium. So we're multiplying the amount of corn times the amount of calcium present in the corn. And remember, that number came from our ingredient composition table that we made at the beginning. This equals 0.015%. Now for alfalfa, 51.5% alfalfa times 1.27% calcium in the alfalfa equals 0.654%. So 0.015% calcium from the corn plus 0.654% calcium from the alfalfa equals 0.669% calcium. Okay, remember, dry matter versus as-fed basis. We divide 0.669 calcium by 0.9. Remember the dry matter content of the corn and the alfalfa, which is equal to 0.74. For phosphorus, 48.5% corn times 0.23% phosphorus in the corn equals 0.111%. 51.5% alfalfa times 0.22% phosphorus in the alfalfa equals 0.113%. 0.111% calcium from corn plus 0.113% phosphorus from alfalfa equals 0.224%. And we divide the 0.224% by our dry matter content to which represents 0.248% phosphorus, okay, on a dry matter basis. So the replacement ewe lambs, which are 66 pounds, have a requirement for calcium at 0.53% of the diet and phosphorus at 0.22% of the diet on a dry matter basis. And if we compare that to our requirements, to the amount of calcium and phosphorus in the diet that we just solved for, we just determined that the amount of calcium in the diet on a dry matter basis is 0.74. So check. Yes, the diet will meet calcium requirements. Now we look at phosphorus. We determined that on a dry matter basis, the diet will contain 0.248% phosphorus. And compared to the 0.22% requirement, yes, it will meet the phosphorus requirements in the diet. Okay, let's try another problem. Let's balance a diet for a 400-pound medium frame steer calf that has an average daily gain, or ADG, of 2.5 pounds. 2.5 pounds average daily gain. Okay, we have at hand corn silage, corn grain, and soybean meal, which I'll abbreviate it as SBM. And the corn grain should be fed at 1% body weight on a dry matter basis per day. So we have a specification here that corn grain needs to be fed at 1% of the body weight, dry matter basis per day. We're also told that we need to include a trace mineral salt at 0.5% of the diet, and that we also need to balance for calcium and phosphorus. And we're told that we have limestone and defluorinated phosphate available as sources of calcium phosphorus that we can use to balance for the calcium and phosphorus. So based on that, how much of each ingredient will be fed daily on an as-fed basis? So remember, very importantly, always pay attention to whether ingredients or requirements are expressed on a dry matter or as-fed basis. So the first step with any diet formulation problem, make your tables. So we have a table for ingredient composition. Okay, so in this table, we have a list of the ingredients. We have corn silage, we have corn grain, we have soybean meal, limestone, and defluorinated phosphate. Okay, then the remainder of the table shows the composition of those ingredients on a dry matter basis. So for the corn silage, corn and the soybean meal, the dry matter content, the crude protein content, the calcium content, and the phosphorus content. And then for the limestone and defluorinated phosphate, the amount of calcium and phosphorus, because they aren't contributing other nutrients to the diet. And you can see limestone is a source of calcium, but not phosphorus. Defluorinated phosphate provides both phosphate and calcium to the diet. So pay attention to that when we get to the point of where we need to balance for the calcium and phosphorus. Okay, so we made our ingredient composition table, which is step 1 for formulating the diet. Then our next step is to state the requirements of the animal. Okay, so we've been told that we need to balance a diet for a 400-pound medium frame steer calf with an average daily gain of 2.5 pounds. Okay, and the requirements are on a percent of diet basis, dry matter. So the requirements are 14.2% crude protein on a dry matter basis, 0.68% calcium on a dry matter basis, and 0.3% phosphorus on a dry matter basis. Okay, next, we know that the steer calf is going to be consuming roughly 11 pounds of dry matter per day. Okay, so we've stated our requirements. So now, okay, what do we need to solve for? We've got corn silage, corn grain, which we've been told has to be fed at 1% of the body weight on a dry basis per day, and we have soybean meal. So we've got a 400-pound calf, and 1% of the body weight would be 4 pounds. Okay, so we know that 4 pounds of that dry matter intake per day has to be coming from the corn grain. Okay, so let's get that out of the way first. Okay, so as I just said, the expected intake for this steer calf is 11 pounds of dry matter per day. Okay, so we just calculated that if we're going to feed the corn grain at 1% of the body weight on a dry basis per day, 1% of the body weight of that steer calf is going to be 4 pounds. So 4 pounds out of 11 pounds of dry matter intake per day times 100, that's roughly 36.36% of the expected intake per day. Okay, so that's important for us to determine because that then determines how much of the diet we're able to use for including the other ingredients. Okay, this will make more sense in a few minutes. Okay, we're also told that we need to include a trace mineral salt at 0.5% and balance for calcium and phosphorus. Okay, so very, very important step here is to list our fixed ingredients. Okay, so the first step was to make an ingredient composition table. The next step was to list the requirements of your animal. The next step is to list your fixed ingredients in the diet, okay, on a percentage basis. Corn grain is going to be 36.36% of the diet. Okay, it's already been specified that the corn grain has to be fed at 1% of the body weight on a dry matter basis per day. We know that the calf is taking in 11 pounds of dry matter per day, so we can then calculate that 36.36% of that diet needs to be corn grain. We're also told that the trace mineral salt needs to be 0.5% of the diet. We're also told that we need to balance for calcium and phosphorus. And this is where it gets a little fuzzy, but it's not difficult. Okay, we know that we have the limestone and the defluorinated phosphate available to use for balancing for calcium and phosphorus, but until we figure out how much corn silage we need in the diet, how much soybean meal, all of which contain calcium and phosphorus, we really won't know how much calcium and phosphorus are deficient in the diet, if they're deficient at all. Okay, so until we figure out how much of those that we need, we really don't know how much of the defluorinated phosphate in the limestone that we'll need to use. Does that make sense? Okay, so what I always do then is, with that in mind, it's kind of gray there, we don't know how much of it we'll need, I always give it a couple of percent. I always fix the calcium and phosphorus at less than 2%. So I'm giving the sources of calcium and phosphorus 1.5% space in the diet. In other words, I'm leaving that space there. So at the very end, there's room for me to balance for calcium and phosphorus if I need to with the defluorinated phosphate in the limestone. Okay, please let me know if that doesn't make sense. Okay, so we always want to leave a little bit of room. I always, as a rule of thumb, less than 2%, fix that so that I've got room at the end of the formulation to balance for my calcium and phosphorus. Okay, so with that being said, if we add together the amount of corn grain, the amount of trace mineral salt that we need to include in the diet, and the 1.5% that we've fixed for calcium and phosphorus so that we've left room at the end to balance for those, that's 38.36% of the diet that's fixed. Okay, if 38.36% of the diet is fixed, how much corn silage and soybean meal do we need to add to the diet? Okay, so if 38.36% of the diet is already fixed to include other ingredients, the amount of corn silage plus the amount of soybean meal, or SBM, would be 100 minus 38.36%, which equals 61.64%. Basically, after we've accounted for our fixed ingredients, the space that we have left in the diet for balancing for corn silage and soybean meal is 61.64% of the diet. Okay, so if corn grain supplies 36.36% of the diet, because remember, corn grain is fixed, it had to be fed at 1% of the body weight on a dry matter basis per day, and we knew that the dry matter intake was estimated to be 11 pounds of dry matter per day. Thus, the corn grain has to be 36.3% of the diet. Okay, we know that 36.36% times 9.7%, which is the amount of crude protein that this corn grain contains, that equals 3.53% crude protein. Okay, so basically, we already have some crude protein being contributed from one of our fixed ingredients, the corn grain. It's contributing 3.53% crude protein. So we're told at the beginning that we need to formulate the diet to contain 14.2% crude protein. Okay, if that's the case, if we want to formulate to contain 14.2%, and we already know that the corn grain, which is a fixed ingredient in the diet, that's giving us 3.53% crude protein, 14.2 minus that 3.53 is 10.67% crude protein. This means the corn silage and the soybean meal must supply 10.67% crude protein because the corn grains in the diet is already supplying the rest. Thus, in order to supply, this is where it gets a little tricky, to supply 10.67% crude protein to the diet, the corn silage and the soybean meal mix has to be 17.3% crude protein. Okay, this is a little tricky to understand at first. This is really important. It's because they are included in the diet at 61.64%. Okay, they don't add up to 100% in the diet like in our previous examples. Okay, we've got fixed ingredients in this example. We've got the corn grain and the trace mineral mix and our sources of calcium and phosphorus. Okay, so the corn silage and the soybean meal aren't being formulated at 100% of the diet. They're only 61.67% of the diet. So the amount of crude protein that they need to contribute to the diet is thus higher because their total amount in the diet is less than 100. Okay, and to calculate that, it's just 10.67% crude protein, which is the amount of protein that needs to be contributed to the diet, okay, from everything else, because remember we said that the corn grain was supplying 3.53% crude protein. So we take that 10.67 and we divide that by 61.64, which is the amount of corn silage and soybean meal in the diet, times 100, and that's 17.31%. Okay, please pay attention to that calculation. Make sure you understand that, because that's where I see a lot of students slip up in these formulations, is they forget that step. Okay, if these ingredients that you're using to formulate for protein don't add up to 100% in the diet, you need to account for that, okay? Because they're essentially diluted out by those other ingredients, they need to be, or the amount of protein that you're formulating for, it needs to be a little bit higher because of that. And I hope that makes sense. But again, look carefully at that calculation. You essentially take the amount of crude protein that you need to formulate for in the diet and divide it by the amount of the ingredients in the diet that you're using to formulate for, and that gives you the amount of crude protein that you need to formulate for. Okay, so that number, 17.31%, is what you put in your Pearson square. Again, please make sure that that's clear, because that's where I see the most students stumble when they're carrying out these formulations. Okay, so 17.31 goes in the middle of our Pearson square. And on the left, we have our two ingredients: corn silage, which is 6.3% crude protein, and soybean meal on the bottom left, which is 48.9% crude protein. So then we subtract our diagonals, always the smallest number from the largest. So 48.9 minus 17.31 is 31.59, and 17.31 minus 6.3 equals 11.01. And the 31.59 plus 11.01 equals 42.6. And those numbers on the right side of the Pearson square are what we then use to determine the amount of corn silage and soybean meal that we need in the diet. So the percent corn silage would thus be 31.59 divided by 42.6 times 100 equals 74.15. And the percent soybean meal would be 11.01 divided by 42.60 times 100 equals 25.85%. But we're not done yet. Okay, you'll notice that the corn silage and the soybean meal percentages add up to 100. But remember, the corn silage and soybean meal don't constitute the entire diet. Okay, remember our fixed ingredients, so we have to account for that now. Okay, so this is another point where I commonly see students stumble in the formulation. So remember that you solve your Pearson square, but that's telling you the proportions of those two ingredients out of 100. And so now we need to account for the fact that those two ingredients are not 100% of the diet. So remember, our fixed ingredients are 38.36% of the diet. Corn silage plus soybean meal are thus 100 minus 38.36, or 61.64%. Okay, so we just solved our Pearson square, and basically what that means is 74.15% corn silage plus 25.85% soybean meal are 61.64% of the diet. Okay, does that make sense? If it doesn't, please let me know. Therefore, the diet composition is, for the corn silage, 45.71%. You basically take the total amount that corn silage and soybean meal will represent in the diet, which is 61.64%. It's 100 minus the amount of fixed ingredients. You take that and multiply that times the amount of corn silage that you determined from the Pearson square, 74.15. So basically that calculation is saying, okay, 74.15% of 61.64% is 45.71%. Now we do the same thing for soybean meal. Okay, 25.85% of 61.64% is 15.93%. And corn grain, as we already determined, is fixed at 36.36%. The trace mineral salt, as we already were told, is fixed at 0.5% of the diet. And our minerals, we've arbitrarily fixed at 1.5% of the diet, just to give us space to balance for the calcium and phosphorus at the end. Okay, for a total of 100%. Okay, so the next important step, once you've completed your Pearson square, then once you've used that plus the information on the amount of fixed ingredients to determine how much ingredients are needed based on your Pearson square results. Okay, now we need to go and update our table. Okay, so here is the complete table, okay, where we enter in all that information. So look on the left, we have a list of ingredients. We've got our corn silage, soybean meal, corn grain, trace mineral salt, and minerals. Right beside that, percent of diet. Okay, so we've now determined that the corn silage is going to be 45.71% of the diet. Soybean meal, 15.93% of the diet. Corn grain, 36.36% of the diet. Trace mineral salt, 0.5%. Minerals, 1.5%. Okay, and they should all add up to 100. Okay, now, looking over on the right side of the table, we have our calcium and phosphorus. Okay, so remember, we want to balance for calcium and phosphorus. So for calcium, we have the percent that's in each of the ingredients, then the amount that's actually in our diet. Okay, so we've got those two columns for both calcium and phosphorus. So for each ingredient, you essentially take the percent of that ingredient in the diet, multiply it by the percent of calcium or phosphorus, and that tells you how much of that mineral is in the diet. So for example, for our corn silage, 45.71% of the diet times 0.38% calcium equals 0.17% calcium in the diet from corn silage. 45.71% corn silage times 0.31% phosphorus in the corn silage equals 0.14% phosphorus in the diet from the corn silage. Okay, you do that for each ingredient. Okay, then at the bottom of the table, you add everything up in the columns. And you can see that for the calcium, when you add up all the calcium that's coming from the ingredients in the diet, from the corn grain, the soybean meal, and the corn silage, we have 0.23% calcium. If we add up all the phosphorus that's coming from those three ingredients in the diet, we have 0.34. Now, beside that, in parentheses, I've listed what the requirements are. So you can see that for the phosphorus, we've already met our requirement, right? The requirement is 0.30, and we have 0.34% phosphorus already in the diet. So we don't need to balance for phosphorus. We're good. But if we look at the calcium, the requirement is 0.68, and we only have 0.23. Okay, so if we take the requirement and subtract it by what we already have in the diet, 0.68 minus 0.23, that's 0.45% calcium that we need to balance into the diet, or we need to include in the diet. Okay, and to do that, we use that space that we've allotted to minerals to balance for the calcium and phosphorus. Okay, so again, looking at this table, there's no need to balance for phosphorus. The requirement is already met in the diet. Now we need to balance for calcium. Okay, so remember, we had two ingredients available to us that supplied minerals, the limestone and the defluorinated phosphate. The defluorinated phosphate contains both calcium and phosphorus. Okay, because we've already met our requirement for phosphorus in the diet, it really doesn't make a whole lot of sense to use the defluorinated phosphate. It's better to use the ingredient that supplies only the calcium. Okay, if we use the defluorinated phosphate, we'd not only be adding the calcium into the diet, we'd be adding more phosphorus. And like I said, we've already met our phosphorus requirement. Okay, so we use ground limestone. So how much limestone do we include? Well, the ground limestone contains 35.8% calcium. We need 0.45% calcium. So very simply, we solve an equation. 0.358 times X. Okay, so the amount of calcium in limestone times the amount of limestone equals 0.45% calcium. In other words, X, how much limestone times the amount of calcium in limestone will give us the amount of calcium that we need in the diet. So we solve for X. X equals 0.45 divided by 0.358 equals 1.26. We need to include 1.26% ground limestone. Okay, so let's go back to our table. Remember, in these diet formulation problems, detailed tables are very important. So let's go back to our table. So what we can now update in our table is the calcium. Okay, so if we look at limestone as an ingredient in the diet, we just calculated that it needs to be 1.26% of the diet. At 1.26% of the diet, okay, it provides 0.458% calcium to the diet. And that meets our requirement for calcium. So if we look at this table now, we've met both the calcium and phosphorus requirement. So remember, at the very beginning, we allotted ourselves 1.5% space in the diet to balance for our minerals. And as you can see here, we only needed to use 1.26% of it to balance for the limestone. So finally, how much of each ingredient will be fed daily on an as-fed basis? So remember, our expected daily intake is 11 pounds on a dry matter basis. Okay, and we want to know how much of each ingredient will be fed daily on an as-fed basis. So if we look at our table, you can see on the left the list of ingredients: corn silage, soybean meal, corn grain, trace mineral salt, limestone, and their respective amounts as a total percentage of the diet. So then in the next column, you can see their dry matter content. And then next to that, you can see on a dry basis the percentage of those ingredients, okay, out of 11 pounds of dry matter per day. Okay, is that clear? So we know that the animal is going to consume 11 pounds of dry matter per day, and we know how much each of those ingredients should be, okay, as a percentage of diet on a dry basis. Okay, so for example, the corn silage is 45.71% of the diet. And if the animal's consuming 11 pounds of dry matter per day, then on a dry basis, 5.03 pounds of that should be corn silage. The soybean meal is 15.93% of the diet. So if the animal's consuming 11 pounds per day, 1.75 pounds of that will be soybean meal. And for the corn grain, it represents 36.36% of the diet. And again, if the animal is consuming 11 pounds of dry matter per day, the corn grain will represent 4 pounds of the diet. So you can see in that column that's labeled dry, okay, the amount of each ingredient in pounds, which adds up to almost exactly 11 pounds. Okay, but the question is how much of each ingredient will be fed on an as-fed basis. Okay, so you remember how we convert between our dry matter basis and as-fed basis. Okay, so basically we take the amount of food on a dry basis, divide it by the dry matter of the ingredient, and multiply times 100 to get the amount of that ingredient in pounds on an as-fed basis. So for corn silage, 5.03 pounds of dry matter divided by 31% dry matter times 100 equals 16.23 pounds. For the soybean meal, 1.75 pounds dry matter divided by 90% dry matter times 100 equals 1.94 pounds of the soybean meal. Okay, and we do that for each of the ingredients: the corn grain, the trace mineral salt, and the limestone. Okay, and we're going to feed this corn silage separately from the supplement. So the corn silage is 16.23 pounds, and then if we add up the pounds from the soybean meal, corn grain, trace mineral salt, and the limestone, the supplement is going to be 6.69 pounds, okay, per day. And then if you look at the last column that I made on the table, okay, if we consider the soybean meal, corn grain, salt, and limestone independently from the silage, because that's our supplement, you can see the percentage that each ingredient contributes to that supplement. So the soybean meal is 29% of the supplement. The corn grain is 68% of the supplement. The trace mineral salt is 0.9% of the supplement, and the limestone is 2.1% of the supplement. Okay, so on an as-fed basis, we're going to feed 6.69 pounds of the supplement plus 16.23 pounds of the corn silage. Any questions?